Okay, so I just wanted to show you a quick video of how you can use Microsoft Excel to calculate the approximate value of the initial value problem shown in example 5.6. You got y prime is equal to x plus y with y evaluated at 0 equal to 1. So what we're going to do here is set up our spreadsheet in much the same way that we did over here. Instead of having x sub n minus 1 and y sub n minus 1 in one column, we're going to split it up into two columns here. And then in the next column we have the function. I can widen this a little bit. Uppercase F is the slope of the tangent evaluated at the previous point. And the reason why it's written like this is because the slope of the tangent is a function of both x and y instead of just a function of x. And then if we move over to the next column, that would be x sub n and y sub n. And then over here I've got the step size. So you'll notice that in the question it says use a step size of 0.1. Okay, so let's take a look at how we could set this up. I'm going to actually delete all of this and we can start from scratch. Okay, so here we go. When x is 0, y is 1. The derivative at that point can be found by simply adding b3 to c3. So the derivative is 1. The next value of x can be found by taking the previous value of x and adding the step size, which is going to be h3. And then to find y sub n, we just need to use this formula here, which is in the OneNote document, and that can be found by simply taking the previous y value and adding to it the derivative evaluated at that previous point, multiplied by the step size, which again is h3. Okay, so there's our next y value located at the point 0.1, 1.1. Okay, so now on the next row, all we need to do is transfer the value that's in E3 to B4. So we just need to say equals E3. And this one is going to be the previous y coordinate, which is right here. And then for this one, all we need to do is drag down to duplicate that formula. And then we can do the same thing here. We can drag down to duplicate these formulas. Oops, I guess that didn't work. I need to double check. Oh, I see. This has to be, I need to change H4 to H3, and I want to make sure that that's an absolute reference. So by pressing F4, when you see the dollar signs $H, $3, that becomes an absolute reference, so that doesn't change. And then the same thing here. I'm going to need to change H4 to H3, and by pressing F4 I can change that into an absolute reference as well. Okay, so there's the new pair XY pair, and so now all I need to do is take all four rows and drag them down. Oops. To here. No, I guess I need to go one more line. Okay. So we were asked to approximate the y value when x is 1, and so there is 3.18748,492. Now the nice thing about setting this up in a spreadsheet is that we can increase the step size or decrease it. So if I want to make this 0.01, then it's going to take me a few more steps to get all the way down to x value of 1. So you can see that after 10 iterations of this, I'm down to 0.1. So what I'm going to do then is drag this down all the way to 100. Okay, so now I've got 1, 3.409627659. Okay, so that's one way to use Excel to generate approximate values in using Euler's method. The second way that I'd like to show you involves using the graphing calculator. So just give me a second to open up Smart View. Okay, so this is not nearly as clean an approach, but basically what we're going to do is take our initial y value, which is 1, and store it in, I'm going to use alpha 1 to make that a y. Okay, so then to find the next y value, what we need to do is take the initial y value, so that's going to be alpha 1, and then what we're going to do is add the step size. So that's going to be 0.1 multiplied by the derivative. Now what's the derivative in this context? The derivative is x plus y, so that's going to be 0 plus the y value, which is alpha 1. And then what does this become? This becomes, we store that as alpha y. So there's your first approximation. Now to get the second approximation, you go second enter, but now what you need to do is replace the x value with the next x value, which is going to be 0.1. Now to do that, you go second delete, and that's going to be 0.1. And I guess I can delete that 0. Okay. And now if I press enter, there's my second approximation. And you just have to continue like this until you get down to 1. And you can see that's going to take us a little bit of time, but it's a little bit quicker than having to enter each formula like I would have done in class in the table. Okay, so just let me carry this through. Remember that our final answer should be 3.81, so we're getting closer. I probably should have shown you this video before I gave you the quiz on Euler's method, but there you have it. Well, I guess 3.18, not 3.81. Okay, so that's the final y value, and you can see that oh, I guess if we had gone back to the step size of 0.1 after 10 iterations, that's the same value that we had there. Okay, anyways, I hope that's helpful.